Hi everyone, welcome back to the channel. And today we're going to solve Leetcode daily challenge, problem number 72, edit distance. So it's a really short problem, but it's a really interesting problem to solve as well. So we will be given two strings, word1 and word2, and we have to basically return the minimum number of operations we would require to convert word1 to word2. And we can perform these three operations, insert, delete, and replace. So it's very similar to a DP problem called longest common subsequence problem, right? So that's what exactly we have to do. So let me explain that. I'll explain it better with an example. Let's say in this figure, we have like I have taken the first example itself. We had horse as word one and ROS as word two. So we have to basically find out a path, you know, with the shortest distance in it. So how do we do that? Basically, on one axis, you will write all your characters from word one. On another axis, you will write your characters from word two. Okay. And now you can see there is an extra row and column, right? In this column, it's basically to handle the edge cases. These columns and this extra row is for basically handling the edge cases. And what exactly it represents is operations performed, like number of operations we'll have to perform for this particular element if there is nothing in word one. Okay. So what do? We basically take this, for example, we took these two characters, right? We will check if these two characters are equal or not. If they are equal, what I'm going to do, I'm going to pick the diagonal value. Okay. If not, what we'll do, we will check for the minimum value within the block right to it, diagonal, and the block below it. And we're gonna add one to the minimum value of it, and we'll populate that. So I have, started populating this table from using a bottom-up approach. That's why you can see this path. Like if I mark this path, it's gonna be, we'll start from here, then going this point, this. Okay. So this was the explanation. Let's go to the programmatical part. Okay. First thing first, I want to handle some edge cases. So let's say if your word one is equals to word two. In this case, I want to return zero, right? Next case is if length of word one is is zero or length of word two is zero. In that case, I want to return the maximum of length of word one or length of word two. Okay. Now comes the complicated and interesting part, the main part basically. Now we need to define a DP array. DP array to represent the metrics which we just saw, right? So to do that, I'm taking a variable called DP and I want to initialize all the values with infinity. Okay, we did this. And how many columns we wanted? We wanted to have length of word 2 plus 1. Okay, I wanted to have these number of columns into the matrix. And how many rows? I wanted the rows to be of length of word of 1, like word 1, right? And this plus 1 will help us getting those extra column and row, which we just saw. Okay, once we are done, those values like in the extra column were pre-filled, right? So I'm going to do that for I in range nth of word 2 plus 1, sorry, plus 1. And what we have to fill in is So basically, we are filling the last column in this case right now. Right? Will be equal to what? Length of what 2 minus height. So if we'll go back to that matrix again, let's go there. Okay, so if we are over here, and if we see what these values are basically, so let's say this we were at index 0 over here, right? And the length of the string was 3. 3 minus 0 is 3. Similarly for 2, 1, and so on and so forth. So that is the exact logic behind filling the extra rows. We're gonna do exactly the same for word, like for our columns as well. Uh, and I. Okay, so it'll be what word 2 and word 1. That is it. Now, a simple DPU function to populate the values for I in range. We wanted to do a bottom-up approach, right? Word 1 minus 1 till we reach to the 0. And similarly for, like we'll need another loop basically for 2 as well. Hmm. We are going to this one. So we have just two conditions. If, what was that? Word 1 at I is equals to word 2 at j, then what we wanted to fill the value with the exact same value which we had at diagonal, right? So PP of I and j is TP of I plus 1, j plus 1. We didn't need to perform any operation on it. Else, what we wanted to do, we wanted to fill the value with 1 plus minimum of all the corresponding values, like values on the right, diagonal, and bottom. So to do that, let me just copy this. Minimum of diagonal, then for below, I'll be using I plus 1 j, and for the right one, we will be using I j plus 1. So this was it. And at the end, I'll just return the value at the 0, 0 coordinate. Yeah, seems fine. Let's check out the test cases. Okay, list index out of range. Why is it so? Word 1 and I, that looks fine to me. Word 1, word 2, word infinite into word 2 plus 1, looks good. Okay, sorry. We use word 1 over here. That's fine. Yeah, so the test cases are clear. Let's submit for further evaluation. And awesome. So the solution was accepted and we performed decent, like we have performed 71.6% of the submitted solution. So yeah. Thanks again guys for watching out the video and stay tuned with the upcoming ones. Don't forget to subscribe to the channel as well. Thank you.